We're going to look at section 10.1. This is day 2, and we are going to be simplifying trigonometric expressions. So we're going to need to know these identities here. These are going to be important. So as you do your homework, you might want to have these written out on a separate piece of paper to refer to. So these three right here are the reciprocal identities. These two right here are the quotient identities. And these last three are the Pythagorean identities. And these are all, again, really important to what we're doing today. So first we want to simplify this expression, sine theta times cosecant theta over cotangent theta. And to simplify, we want to, if possible, rewrite these so that they're in the fewest terms possible. So for this example, we might want to try to rewrite it so that we only get one trig function instead of something in terms of 3 trig functions. So a smart thing to do on all of these is you want to try to rewrite these trig functions in terms of sine, cosines, or tangents, because those are kind of the most basic trig functions. So the first thing I might do is rewrite cosecant and cotangent in terms of those sine and cosines. So let's go ahead and do that. So cosecant is, well, let's see. Sine is 1 over cosecant, so cosecant would be 1 over sine. So let's go ahead and rewrite that. 1 over sine theta. And cotangent is cosine theta over sine theta. Now you'll notice that on the top we get sine theta over sine theta, and that'll cancel to be just 1. And that is 1 over cosine theta divided by sine theta. Now we don't like fractions within fractions, so let's go ahead and multiply the top by the reciprocal of the bottom. So that'll give us 1 times sine theta over cosine theta. And 1 times anything is that anything. And then we notice that sine over cosine is just tangent. So this expression can simplify into tangent theta. Alright, let's go ahead and do another one. Okay, so this example is a little more complicated. And again, we want to try to simplify this into maybe 1 or 2 just trig functions, the smallest amount that we can have. So whenever I see something squared, I know that I might use a Pythagorean identity. Let's go ahead and rewrite these in terms of sine or cosines if possible first. So tangent squared would be sine squared over cosine squared. Cosecant squared would be, let's see, 1 over cosecant is sine, so cosecant would be 1 over sine. So that will be 1 over sine squared. And then minus 1, and secant squared, that would be 1 over cosine squared. Okay, let's go ahead and simplify things if possible. Sine squared over sine squared will cancel. So this will give us, let's see, 1 over cosine squared. Oops. Minus 1 over 1 over cosine squared theta. And again, we don't like fractions within fractions, so let's multiply the top and bottom by the reciprocal of the bottom. So that'll be 1 over cosine squared theta minus 1 times cosine squared over 1, which is just cosine squared theta. Okay, if we distribute that, we get cosine squared theta over cosine squared theta minus cosine squared theta. And then you'll notice that cosine squared over cosine squared should just be 1. So that's going to give me 1 minus cosine squared theta. Okay, now this is where the Pythagorean identities come into. So you'll notice up here that we've got a cosine squared and a 1 in this trig identity. So we want to think, is there a way we could rewrite this so that it matches 1 minus cosine squared theta? And there actually is a way we can do that. If we subtract cosine squared theta from both sides, we will get sine squared theta is equal to 1 minus cosine squared theta. Therefore, 1 minus cosine squared theta equals sine squared theta. We can rewrite this green expression as simply sine squared theta. And that would be our simplified function. Okay, let's do one more. Okay, again, when you're starting out with these, you want to try to rewrite them in terms of sines and cosines, and then maybe tangents. So we'll see we have a 1 minus cosine squared here, which if we look up at our last example, we rewrote that as sine squared. So we can go ahead and do the same with this one. So this is just sine squared theta. And secant is 1 over cosine, because cosine is 1 over secant, so if you multiply both sides by secant, divide by cosine, you get secant equals 1 over cosine. So 1 over cosine theta, and that is all over sine theta, and that is being multiplied by sine squared theta. Now we can go ahead and simplify this, so sine squared over sine is just sine. So that cancels with one of those. We get 1 over cosine theta times sine theta, which equals sine theta over cosine theta. And then we look at our trig identities and see if we can simplify that to anything. So sine over cosine actually equals tangent. So this can be simplified to just tangent theta. Okay, so the trick to doing these is to try to change the trig functions in terms of sine and cosines, and sometimes tangent is helpful as well. And notice anything really squared, you might want to consider looking at the Pythagorean identities and try to rewrite it so that we can substitute some trig function into that.